connected in series. Why? Because these resistances are connected on a single wire. If you are connecting resistances on a single wire, suppose this is a wire, and on this wire, if you are connecting resistance, okay, if you are connecting one end of the resistance to the another end, you can see here uh, for this resistance R1, this end of the resistance, this end of the resistance is connected with another end of the resistance. So basically this combination is a series combination, and remember one thing, in series combination current through each resistance is same. Current through each resistance is same. You have to remember this point. Hello, Martin. Okay, Martin. So we are discussing resistances in series. Very easy topic.
Okay, sir.
Yeah. So here you can see I already written so as to save the time. So current through each resistance in series is same. Okay, and this is a cell connected, or you can connect a battery also. This is a cell connected. This is a positive end of the cell. This is a negative end of the cell. So current will flow from positive to negative terminal, positive to negative. Okay, so current will flow like this, and across each resistance, the current will be same. But the potential difference across R1, R2, R3 will be different. Suppose V1 is the potential difference across R1, V2 is the potential difference across R2, and V3 is the potential difference across R3. Okay? Okay. Now this is the potential difference V, and this is the potential difference of a cell here. So we can say that this potential difference V is divided among R1, R2 and R3. So I can write, this V is equal to V1 plus V2 plus V3, because this V is dividing into this V is dividing among R1, R2 and R3. So I can write V is equal to V1 plus V2 plus V3. Okay. Okay. After this, these are the three, we have taken the three resistances. Okay, we have taken three resistances. Now I am removing these three resistances and connecting an equivalent resistance of these three resistances. Means you can see here, means I am connecting a single resistance like this, and this resistance is the equivalent resistance of R1, R2 and R3, and this is the cell connected, and current is flowing like this, no problem. Okay, so for this circuit, can I write V is equal to I into Re? For this circuit, can I write V is equal to I into Re? Okay,
Yeah.
now come here. So this is V. V can be written as I into Re. Now V1 can be written as I into R1 because V is equal to IR. So we can write V1 is equal to I into R1. V2 can be written as I into R2. V3 can be written as I into R3 because current across each resistance is same. So now here is I into Re is equal to I. Take I common from here, and from here. You will get R1 plus R2 plus R3. Now this I and I will be cancelled out. So the equivalent resistance formula, you will have R1 plus R2 plus R3. Okay. Now If instead of these three resistances, four resistances are connected in series, so what will be the equivalent resistance? R1 plus R2 plus R3 plus R4. If suppose five resistances connected, R1 plus R2 plus R3 plus R4 plus R5. Okay. So I have written here, if n number of resistances are connected, n can be any number, n can be 100, n can be 200, n can be 1000, n can be 10. So if n number of resistances are connected in series, then equivalent resistance is equal to R1 plus R2 plus R3 plus R4 and so on plus Rn. What is Re? Re is the equivalent resistance. Okay. Remember this point, in series, current through each resistance is same. Okay, so this question. A resistance of 6 ohm, a resistance of 6 ohm is connected in series with another resistance of 4 ohm. So basically here in this question, there is a resistance of 6 ohm, okay, and this is connected with a resistance of 4 ohm in series. Okay, this is the series combination. A potential difference of 20 volt is applied across the combination. So a potential difference of 20 volt is applied across the combination like this. Means a cell is connected in this form. Calculate the current through the circuit. Okay, they are asking current through the circuit and the potential difference across 6 ohm resistance. Means we have to calculate the potential difference across this. Suppose this is V1. V1 is the potential difference across 6 ohm. Okay. I am adding from my side. Calculate this also, V2 also. This I am adding from my side. This is not given in the question. So we have to find the potential difference across 6 ohm and 4 ohm. Now, what will be the equivalent resistance? Because this is a series combination. In series combination, equivalent resistance is R1 plus R2. So equivalent resistance is equal to R1 plus R2 means 6 plus 4, 10 ohm. This will be the equivalent resistance. Okay. So you can remove these two resistance, and instead of these resistance, you can connect a resistance, equivalent resistance of 10 ohm. Okay. And here battery or cell is connected of 20 volt. And this is the current. So from here you can find V is equal to IR. You can write V is equal to IR. What is V? V is 20. Current you want to find, and here you will take RE. V is equal to I into RE you will take. So RE is 10 ohm. So current will be 20 by 10. So current will be 2 ampere. 2 ampere current is flowing through the circuit. Now to this 2 ampere will flow across 6 ohm as well as across 4 ohm, because this is a series combination, and in series combination current through the resistance same. So across this 6 ohm the current will be 2 ohm 2 ampere, and across this 4 ohm also the current will be 2 ampere. So you can find V1. V1 is equal to current I into R1. What is I? I is 2, R1 is 6. It will be 12 volt. Okay. V2 you can find either in this way. V2 you can write I into R2. Current is 2 and R2 is 4. So it will be 8 volt. So now you can add 12 plus 8. It is becoming 20. or in this way also you can find total voltage is equal to voltage across 6 ohm plus voltage across 4 ohm, means V1 plus V2. So V is given as 20 volt. V1, you have find it out already, V1 12 volt, so it is 12. So now from here also you can find V2. 20 minus 12, 8 volt. Okay, 8 volt. Now parallel combination. We will discuss parallel combination. Okay. See here. If resist, but before that, you should know in parallel combination, in parallel, potential difference or voltage across each resistance is same. In parallel combination, voltage is same across each resistance. In series combination, current is same across each resistance. Now this R1, this is R1, this is R2, and this is R3. These are connected in parallel combination, end-to-end connection. Okay, you can see one end of R1 is connected to another, one end of R2, one end of R3, and another end of R1 is connected to another end of R2 is connected to another end of R3, and here a battery is connected or a cell is connected, you can say. So from this cell, the current will flow like this. So this is the current I flowing in the circuit. Now this is the junction point. From this point, there are three branches. One branch, two branch, three branch. So this current will be divided among the branches. So this I will be divided as I1 is going across R1, I2 is going across R2, I3 is going across R3. But we know that the potential difference across each resistance is same. So potential difference across R1 is V, R2 is also V, R3 is also V. Okay. So can I write this I is equal to I1 plus I2 plus I3, because I is dividing among R1, R2 and R3. I can be written as I, because you are dividing this I. This is like this water is flowing in this pipe. This is a pipe. Okay, this is a pipe, and in this pipe the water is flowing. Now here three pipes are connected. From this supply or from this pipe, the water will go in this pipe also, in this pipe also, in this pipe also. So you can say the amount of water that is flowing in three pipes is equal to the amount of water flowing in this pipe. So basically current I is equal to I1 plus I2 plus I3, you can write. Okay. Now after that, instead of these three resistances, I am just connecting an equivalent resistance. Okay. Instead of these three resistances, I am connecting an equivalent resistance, and battery cell is connected V, and current will flow like this. So I can write current expression I is equal to V by R, because V is equal to IR. So from here, for this circuit, okay, for this circuit, I can write I is equal to V by R, and RE is the equivalent resistance. Now come here, this I, from here we can write V by RE, V by RE, very good. Now I1, this I1 can be written as V by R1, I1 can be written as V by R1, I2 can be written as V by R2, I3 can be written as V by R3. Okay, now take V common from here, and this V and V will be cancelled out. You will get the equivalent resistance as 1 upon equivalent resistance in parallel combination is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. If more than three resistances are connected, suppose five resistances are connected in parallel combination, then how you will calculate the equivalent resistance? 1 upon R1, 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4 plus 1 upon R5, and so on, if more resistances are connected in parallel. So for n resistances connected in parallel, 1 upon RE can be written as 1 upon R1, R2, R3, R4, and so on, and 1 upon Rn. Remember this point, in parallel combination, potential difference or the voltage across each resistance is same. Okay, so see this question. This is very easy question. Okay, we will not solve this question. Calculate the equivalent resistance when two resistances of 3 ohm, 3 ohm, when this 3 ohm and 6 ohm are connected in parallel. So this 3 ohm and 6 ohm are connected in parallel. You will apply this formula 1 upon R is equal to 1 upon R1 plus 1 upon R2. You will put the value. You will get the equivalent resistance as 2 ohm. Now, here is the important point. If two resistances are connected in parallel, this result will be used. So I am removing this question. This is very easy question. So no need to solve this. Okay. If two resistances if two resistances are connected in parallel, connected in parallel. Now you can see here. So how you will calculate the resistance? Suppose resistance R1 and R2 are connected in parallel. So equivalent resistance 1 upon R1 plus 1 upon R2. So you will take the LCM R1 into R2 and this will be multiplied by this and this will be multiplied by this. It will become R1 plus R2 divided by R1 by R2. So equivalent resistance will be this R1 R2 divided by R1 plus R2. For example, if I am saying 5 ohm and 10 ohm are connected in parallel, find the equivalent resistance. So what you will do? Suppose this is R1 and this is R2. What you will do? R1 R2 divided by R1 plus R2. So what is R1? 5 into 10 divided by 5 plus 10. It will be 50 divided by 15. This will be your answer in ohm. Okay, so this question we will solve now. Okay, so we will solve this question. See. Okay, just a minute. In the circuit diagram, given alongside, find total resistance of the circuit. Means this is a circuit diagram. So for this circuit diagram, first you have to calculate the total resistance of the circuit. After that, total current flowing in the circuit. After that, the potential difference across R1. The potential difference across R1. Three questions are there and we will solve that. Basically, you can see here, this 8 ohm and 12 ohm are connected in parallel because this is end-to-end connection. You can see here, this 8 ohm and 12 ohm are connected in parallel. But with this 8 ohm and 12 ohm combination, this 7.2 ohm is connected in series. Basically, this is a mixed combination. This is a mixed combination. Series and parallel at the same time. Okay. Okay. So this is R1, R2 and R3. So you can solve very easily. You can say that R1 and R3 and R2 are connected in parallel. R3 and R2 are connected in parallel? So if they are connected in parallel, means, so we can find the equivalent resistance. So equivalent resistance of R3 and R2 I will represent with R23. Okay. So it will be the product of two resistance divided by the sum of two resistances. So you can write R2 multiplied by R3 divided by R2 plus R3. So R2 8, R3 12, R2 8, R3 12. It will be 8 into 12 divided by 20. 4 2s are 8, 4 5s are 4 2s are 8, or 4 5s are and it will become 0.4. So it will become 4.8. 4.8 ohm. So basically the equivalent of this and this is 4.8. Now you can say that here. Now you can say that this whole resistance is basically this whole combination having a resistance of R23. Okay, and that is equal to 4.8 ohm. So now what you can say? See this as a one resistance of 4.18 ohm. So now you can say this 4.18 ohm is connected in series with R1. So you can say that this R23 and R1 are connected in series. So equivalent resistance of this and this 4.8 will be 7.2 plus 4.8. So you can write it as R123. R123 is basically the equivalent resistance of R23 and R1. It will be R23 plus R1 because they are in series. In series, we will add resistances. So it will be 4.8 plus 7.2. It will be 12 ohm. So basically, this is the equivalent resistance of the circuit. This is the total resistance of the circuit. Okay, so this is answer number A. Now after this, very easy. The question becomes very easy. This is the total resistance. So answer number B. You can instead of this whole combination, means no need to do that. They are asking the total current now, total current in the circuit. So I am saying that I is the total current. So I is equal to potential difference divided by the total resistance. So potential difference V and total resistance is R 1 2 3. So what is the potential difference? 6-volt battery is there. So it will be 6 divided by R123 is 12 ohm. So it will be 0.5 ampere is the current. 0.5 ampere current is flowing. This is a circuit. So you can say that in this circuit, the current of 0.5 ampere is flowing, means in this resistance, the current of 0.5 ampere will go. Okay, this is the current I. So now they are asking answer number C. The potential difference across R1 means this is potential difference across R1, I am considering it as V1. So V1 can be written as current I into, so consider this as I1. So I1 into R1. So it will be 0.5 and R1 is 7.2. So you will get 3.6 volt. This is the answer number C. Right, total current, how you will find the total current? Total current will be total voltage divided by total resistance. Total voltage is this, total resistance is 12 ohm. Aman and Hamna, Martin, Abdullah, are you getting?
Yes, sir.
Okay. If you want to ask any doubt, then you can ask me, no problem. Otherwise, you should write this. Okay, write down fast. So always remember, in series combination, the current across or current through each resistance is same. In parallel combination, the voltage across each resistance is same. And identify what is series combination and identify what is parallel combination. In series combination, the potential difference across different resistances will be different. In parallel combination, the current across current through different resistance will be different.
Yeah, done, sir.
Okay. Write on this also first. Okay. Completed? Done?
No, done, sir.
Okay, okay. Fine. Scroll down.
Yeah, scroll down.
Completed.
Yes, sir.
Yes.
Okay. Okay.
Your answer.
Okay. Completed.
Yes, sir.
Okay. Completed. Martin completed.
No.
Scroll down. Scroll down.
Yeah, 1 minute, sir. Almost done.
Okay. No problem. Hamna completed.
Clear answer.
Okay. So once again, you should draw this diagram and show in this diagram. This is V1. Answer C. This is answer C. Answer of question number C. Okay, so today I will take half an hour extra. All of you. Okay, Martin and Eamon and Hamna.
Yes, sir.
Because we have to complete the syllabus also all time, and as you know that there is only one class, and that is of 1 hour, and that is also in 1 week. In 1 week we have 1 hour, and in that 1 hour my teaching time is basically 40 minutes. 20 minutes is going in noting down by you. That's not a problem. I'm not saying that's a problem, but basically what the content I am delivering you is basically of 40 minutes in 1 week. So that is not enough, I think. So today I will finish this chapter in half an hour. And after that, last chapter will be the magnetic effect of current. And Martin, is there sources of energy is there in your syllabus
No, sir.
of deleted na?
Yeah.
So basically there is only one chapter left, that is magnetic effect of current, and obviously I can complete that on time, so that there will be the time of revision also for you. I don't know whether you have completed in your school or anywhere else, but from my side, I will complete on time. Then if you want, then if you will continue the classes, then we can do the revision. Otherwise, you can study by yourself, depending upon you. Because once you have read something, so after some time, you are getting, means you are forgetting it after some time. With me also, with each of the human, this process happens. So to learn the thing or to know the thing for longer time, there is a need of revision. And revision is possible when the syllabus will be completed on time. So basically you can say it is a game of time. Done? Okay, write down. Martin completed. Aman completed.
Good answer.
Amna, beta, you can
Answer.
write in the chat box if you.
Good
Yes.
answer.
Okay. Okay. So after this, we will start the power. Basically, what is power? The rate of doing work is power. Suppose there are two persons, A and B. There are two persons, A and B. Suppose two person are there, A and B. Okay, fine. Person A is doing a 20 joule of work. There are two person, A person and B person. This A person is doing 20 joule of work in 10 seconds. And this B person is doing 200 joule of work in 20 seconds. So we have to tell which person have more power. Which person have more power. So when you will calculate the power, basically power is rate of doing work. Rate of doing work means work divided by time. Work done per unit time. So work done is 20, time is 10, work done is 200, time is 20. It will be 2, power is 2 for A, and it will be 10 for B. Unit we will discuss later. Basically the unit of power is what? SI unit. So the power of B is greater than power of A. So this is the concept of power is equal to work done divided by oh. Oh, actually sorry. Basically the power is energy per unit time. Power is energy per unit time, not work per unit time. Basically work rate of doing work is energy. Actually that thing I told you na, that was for energy. Now power is something else. Power is energy per unit time. Okay, and power is energy per unit time. Okay. Oh shit, what I am doing. Power is work done divided by time. Okay, fine. So electrical power is work done divided by time. Okay, so that example was correct. Okay, so electrical power is electric work done divided by time. Electric power is electric work done per unit time. Okay, electric. What is the meaning of the electric work done? Electric work done means you are supplying the electrical energy to your laptop, to your mobile phone, to your laptop. Take the example of your laptop. Electrical energy is supplied Okay, basically due to that electrical energy work is done. Okay, and that work done divided by time is power. So power is equal to work done divided by time. Okay, power is equal to work done divided by time, and unit of power you can calculate from here. Power is work done, unit of work done is joule, power of unit of time is second, so joule per second, and this joule per second is also known as watt, James Watt. Okay, there are three formulas to calculate power. One formula is power is equal to potential difference multiplied by the current. Potential difference multiplied by the current. Another is you can derive another formula. You know that P is equal to VI, and you also know that V is equal to IR. Put the value of V is equal to IR, and II will be multiplied become I square and into R. So this is the second formula. Now third formula you can get. You know that V is equal to IR. From it you can calculate I. So put the value of I here. So I is equal to V by R. So it will be V square by R, and R will be cancelled out. So third formula of power is equal to V square by R. Remember, P is equal to V I, P is equal to I square R, P is equal to V square by R. Okay. Hmm. Hmm. Okay. Now question. All of you focus on the screen. Okay. This topic is very easy. Today only I am taking the class of 1 plus half hour. Okay. Okay, now you can see this question from NCERT. An electric bulb is there. This is an electric bulb. This electric bulb is rated 220 volt and 100 watt. So what is the meaning of this? Means the power of this bulb is 100 watt. Okay, and this is rated as 220 volt. Rated 220 volt means maximum amount of voltage you can give it is 220 volt. So basically when you go to the market and when you will purchase the bulb, this rated value and the power of the bulb will be given on that. So basically from this you can calculate the resistance of the bulb. So you know that power is equal to V square by R. Three formulas are there. No? First formula, power is equal to V into I. Second formula, P is equal to I square R. Third formula of the power, V square divided by R. So accordingly you will apply the formula. So apply formula number third, V square by R. So from here calculate R. R is equal to V square by P. Okay. So resistance will be V square. V square means 220 square divided by 100. 22 multiplied by 22. 44. 44. 484. So it will be resistance of the bulb will be 484 ohm. Now when it is operated on, this bulb now operated on 110 volt. So basically this bulb is now operated on 110 volt. Means the supply voltage to this bulb is 110 volt. And they are asking the power consumed. So they are asking when you will give 110 volt to this bulb, a supply of 110 volts, then how much power will it consume? So power you want to find. So apply again this formula, power is equal to V square divided by R. V square means 110 square and resistance is 484. So it is what can you do? Hmm. Hmm. It will become 22, 22, 484. So you can write 11 into 11 multiplied by 100, and you can multiply by 4, and here is 484. So 11, 11 is 121, and 121, 4 is equal to 484. So basically this will be cancelled out, it will be 100 watt. Is it right or wrong? Okay, so we will cancel this. Okay, so from 4, 4 ones are 4, 4 twos are 8, 4 ones are 4, and 4 twos are 8. It will not be cancelled from 4. So we will cancel it with 2. So cancel this with 2. It will be 55. It will be 242. It will be 55. It will be 121. So now we have 55 multiplied by 55 divided by 121. Now it will be 11 fives are 55, and 11 11s are 121. And now cancel this with 11. Okay, so 5 fives are 25 watt will be the answer. 25 watt will be the answer. Now next question. Very easy. Now you have to solve this question. Which of the following does not represent the electrical power in the circuit? Which of the I square R is correct? Okay, I square R is correct. VI correct. V square by R are correct, and this option is incorrect. So no need to write this question. This is a very easy question. Okay. Okay, Aman. Okay, Martin and Hamna, understanding? You have to just apply the formula and get the answer. Martin, got it?
Yes, sir.
Okay, so write down fast all the formulas. You should learn P is equal to VI, P is equal to I square R, P is equal to V square R. And I have also done this so that you should know from where these formulas are coming. Write down. This time write down fast. All of you.
Right answer.
Okay. If you have not completed, na, you can ask me to scroll up also. Okay. Power is equal to work done divided by time. Hmm?
Right answer.
Okay, good. And Martin,
Yes, sir.
completed now?
Yeah,
And
yes.
Eman, Eman completed.
Yes, sir.
And Hamna, okay. Okay, write down this question. You are in 10th class. You all are in 10th class. So means calculation. I think you can do these types of calculation, is multiplication and all that. Completed?
Also,
Okay, okay. So the option will be option number D. Okay, here the option number D, option D will be correct. 25 watt. Done with completed?
yes, sir.
Okay. So are you getting it or not?
Yes, sir.
Okay. Electrical energy. So this is electrical energy. Basically, there are many types of energy. Hmm? There are many types of energies are there. For example, kinetic energy. Kinetic energy means if suppose any body is in motion, so at that time, hmm, due to the motion, due to the motion, the energy possessed by the body is kinetic energy. Another energy is potential energy. Potential energy means suppose this is the ground. Okay, this is the ground and this is some body. If I am taking this body up, it means that the potential energy of the body will increase. Hmm? Due to height, the potential energy of the body will increase. So due to the position or configuration, the energy possessed by the body is the potential energy. Many types of energies are there. Hmm? And electrical energy, due to electrical work done. So basically, you should know what is the electrical energy and what is the formula of the electrical energy. Okay. So basically, electrical energy is the product of electric power and time. Electrical energy is the product of electric power and time. P is the electric power, T is the time. For example, suppose you have a laptop. This is your laptop. Okay. This is a space bar button, and this is your laptop. Okay. Okay. So this laptop is consuming. I mean, this laptop is consuming the power of 25 kilowatt, not kilowatt, 120 watt. Okay. This laptop has has the power rating of 120 watt. Okay. Now this laptop suppose running for 1 hour. Now in this case, what is the energy is what is the electrical basically to run the laptop? What type of energy you will give? Electrical energy you will give. Okay, somehow you will give the electrical energy. This is the socket and this is the wire, and you will connect the wire here. So from this is the source of electric energy. From here, electrical energy is provided to this laptop, and this laptop is working for 1 hour, and power rating of this laptop is 120 watt. So in 1 hour, how much energy is spent? How you will calculate? That energy will be power multiplied by time. So what is power? 120 watt. Time is 1 hour. 1 hour means 60 into 60 seconds. So this much energy, this much joule of energy, because unit of energy is also joule. So this much joule of energy will be consumed. Okay. So basically energy is power into time. Unit is joule. 1 kilojoule is this 10 to the power 3 joule. Now, generally what happens in the general life, you can say, we have devices like laptop, we have a refrigerator, television, air conditioner, many electrical appliances we have. So basically, generally, they run for half an hour, they run for 1 hour. So basically, they spend a large amount of energy. They spend a large amount of energy. Okay. So that is why we use another unit of energy other than joule, that is commercial unit of electrical energy, and that is bigger unit of electrical energy. Okay, that is bigger unit of electrical energy we use. And why we use? Because in general life a large amount of electrical energy is used. Okay, suppose if I am saying that 1 kilo uh, 1000 watt energy is consumed, so that is 1000, sorry, 1000 joule of energy is consumed. So you have to take into account the 1000. Okay, for the commercial unit, okay, that 1000 will be much less. You can understand. uh, Commercial unit of electrical energy is the kilowatt hour. Commercial unit of electrical energy is kilowatt hour. Okay, and in 1 kilowatt hour, how you will convert 1 kilowatt hour into joule? Basically 1 kilowatt hour is the bigger unit of electrical energy, and this is the commercial unit of electrical energy. In general life, in general, for general purposes in our home, generally we use this unit. Okay, we say that in the electricity bill, suppose you have to give the electricity bill. So they will say in this month, this much of kilowatt hour of energy you have consumed. Okay, so they will say this much joule of energy you have consumed. I think now it's okay. So 1 kilowatt hour, how you will convert 1 kilowatt hour into joule? So in 1 kilowatt there are 10 to the power 3 watt, and in 1 hour there are 60 into 60 seconds. So when you will multiply this, you will get 3.6 into 10 to the power 6 joule. So always remember that, and you can write here, energy is power into time. Unit of energy is watt, and unit of time is second. Watt second is also known as joule. Okay. Now in 1 kilowatt hour, there is 3.6 into 10 to the power 6 joule. In 1 kilowatt hour, there are 3.6 into 10 to the power 6 joules. Okay, write down fast. Energy is equal to power multiplied by time. Okay. So, in the next class, we will finish this chapter. Okay. And we will start the new chapter, magnetic effect of current. Very important chapter, magnetic effect of current. So basically, there we will see due to current, there will be the magnetic field and there will be the magnetic effect due to the current. Okay, write down. You have to remember commercial unit of electrical energy is kilowatt hour. Simple. And in 1 kilowatt hour, there are 3.6 into 10 to the power 6 joule.